Have you ever wondered what lies above and below our solar system? Not just gazing at the stars, but truly considering where we are within the vast expanse of the Milky Way? Our solar system is not just a collection of planets orbiting the Sun. It's part of something much larger and more complex, a true cosmic neighborhood within the galaxy. In this video, we'll explore what lies above and below the solar system, going beyond the idea of a flat space. With a three-dimensional perspective, you'll discover how our position in the galactic disk influences not only what we see in the sky, but also what protects us from intergalactic dangers. Get ready to see the cosmos in a completely new way. The Milky Way, our galactic home, is a massive spiral disk filled with billions of stars, planets, and stellar systems. Spanning approximately 100,000 light-years in diameter, it is structured like a cosmic pancake, where most of the activity occurs in a thin, flattened plane. The solar system is located in a region called the Orion Arm, one of the smaller spiral arms, about 27,000 light-years from the galactic center. Here, it orbits the galaxy's core at a calm speed of 828,000 kilometers per hour. But what does above and below mean in this context? These directions are determined in relation to the galactic plane, an imaginary line dividing the Milky Way in half. Above it is up, and below it is down. This reference helps us better understand how our position influences what we observe in the cosmos. Now that we know where we are located, it's time to look upward. Above the galactic plane lies an enormous region known as the galactic halo. This area surrounds the entire Milky Way and is made up of ancient stars, hot gas, and most mysteriously dark matter. The galactic halo extends far beyond the visible part of the galaxy, containing billions of stars and other structures we cannot see directly. But what does this mean for us here in the solar system? The galactic halo has a direct influence on our cosmic environment. For instance, it is responsible for the presence of cosmic rays, high-energy particles traveling through space that can affect our atmosphere. These rays, in extreme cases, can impact life on Earth by interfering with satellites and even influencing space weather. Additionally, the halo is home to runaway stars, those that have been ejected from their original systems and now travel across space. These stars move at incredible speeds, and while they are far away, their passages can disrupt the solar system's environment, like a stone thrown into a calm lake creating ripples across the surface. Interestingly, the magnetic field of the heliosphere, the protective bubble surrounding our solar system, helps shield us from these particles and radiation from the galactic halo. Even billions of kilometers away from the galactic center, the solar system is affected by these phenomena, demonstrating how interconnected everything in the cosmos truly is. Now let's look downward, toward the other side of the galactic plane. Below us are the molecular clouds, vast regions of gas and dust that are the true factories of new stars. These clouds are cold, dense, and composed primarily of hydrogen, the most abundant substance in the universe. However, what makes them special is the process that occurs within them: star formation. These clouds are stellar nurseries, places where new stars and planets form from the condensation of gas and dust. When part of a cloud collapses under its own gravity, the material begins to heat up, starting nuclear reactions and giving birth to new stars. This process is one of the most fascinating in astrophysics, as it is the origin of stars that will eventually form planetary systems. Furthermore, these molecular clouds are located a few hundred light-years below the galactic plane and have a significant influence on the galaxy's overall formation. They can affect the stellar density in different parts of the Milky Way, creating regions with higher or lower concentrations of stars. The gravity of these clouds also impacts the movement of the solar system, causing fluctuations in its orbit over time. Interestingly, these clouds also play a vital role in the universe's chemistry. They contain a wide variety of complex molecules, some of which are essential for the formation of life. In other words, below the solar system, The cosmos is literally manufacturing the conditions for the next generation of stars and planets, and perhaps new forms of life. Now that we understand what lies above and below the solar system, it's time to see how these regions directly influence our planet and our stellar system. The solar system is not a stationary body in space. It constantly moves in its orbit around the center of the Milky Way. During this journey, the solar system passes through different regions of the galaxy, including the galactic halo and the molecular clouds below the galactic plane. This movement is not without consequences. For instance, when we cross the galactic plane, we may be exposed to more intense cosmic rays, which can affect Earth in various ways, from damaging satellites to potentially impacting the planet's biodiversity. Moreover, this crossing may be linked to mass extinction events, as some theories suggest, due to increased cosmic radiation affecting the atmosphere. Another significant impact comes from interactions with molecular clouds. As we've seen, these clouds exert a strong gravitational force, which can influence the solar system's orbit, either speeding it up or slowing it down as it travels through the galaxy. These variations can affect the long-term stability of the solar system, demonstrating how the above and below have real, albeit indirect, effects on our daily lives. Looking up and down from the solar system provides a completely new perspective on our place in the universe. Above us, the galactic halo is a region filled with solitary stars, cosmic rays, and dark matter, subtly but significantly affecting our solar system. Below, the molecular clouds play a crucial role in forming new stars and planets while influencing the gravity of the solar system and its orbit within the Milky Way. Understanding these interactions helps us realize that, even though it may seem like we're floating alone in space, we are deeply connected to the vast and dynamic cosmos around us. Every movement, every burst of cosmic radiation, and every cloud of gas shapes not only our solar system, but the galaxy itself. This is just the beginning of our exploration of the cosmos. With each new discovery, we expand our view of the universe, and in turn, our understanding of ourselves.